Hey, welcome to another episode of the On.NET Show. Today we've got Aaron Stannard, and he's going to be talking to us about Akka .NET. Thanks for being on the show, Aaron.
Thanks, Rich. Much appreciated.
Yeah, so you work on the Akka .NET project and at Petabridge. Kind of tell us a little bit about both, and we'll kind of then get into the main topic.
Sure. So I'm the lead maintainer of the Akka .NET project, and I'm one of the founders dating back to the very beginning. And my role sort of in the open source project over the years has really been to sort of just ensure that there's like production grade quality behind everything we do. And I also maintain most of the code inside the remoting and clustering systems. So that's what I do on the project. Petabridge, my company, has been around for a little bit over 3 years now. We provide commercial support, training, and actually pretty soon we're going to be launching a proprietary DevOps suite for managing large Akka .NET clusters pretty soon. So that's what we do, and basically it's all sort of done in our sort of philosophy behind Petabridge is basically to make it really easy for .NET developers to build applications that scale. That's what we do.
Okay, that sounds like a good plan.
Yep.
Okay, so tell us a little bit more about the space. I think there's this actor model, and maybe you can tell us a little bit about other implementations that might be kind of similar, kind of different.
Sure. So Akka .NET's an implementation of the actor model, right? And the actor model is actually a really old concept, been around since the early 1970s. Today, in 2018, there's a few different implementations that are available. There were none when we started the Akka .NET project, so that's a big improvement right there. But you have Akka .NET itself, which is a port of the really popular Scala project called Akka. And Akka is used to power things like Apache Spark and a whole bunch of other systems under the hood. So you have Akka .NET, which is a port of that, and it operates in a very similar manner to Erlang and some of the other sort of traditional actor model implementations. We also have some new interpretations of that design, like Microsoft Orleans and Service Fabric actors, which both implement this virtual actor model, which has some semantic differences in terms of how actor lifecycle works and everything else. But really, they're trying to accomplish the same goal, which is making it really easy for developers to build applications that can distribute large concurrent workloads somewhat transparently over flexible networks. So you can go ahead and add and remove computers on demand using something like a Windows Azure scaling set and get a linear increase in the amount of computing capacity that you have.
Makes sense. So definitely heard this term actor before. Can you give us more of a sense of what the nature of it is and if it's similar to anything else?
Sure. Well, from the original actor model white paper from the early 1970s, the actor model white paper itself was only like a couple years younger than the original relational database white paper, just to give you a sense of how old these ideas are. And the actor model was originally developed as a means of doing really high concurrency programming, because computer scientists at the time envisioned that the way major sort of networks and server-side applications would be built would be these big computers that would take up a massive amount of space and have thousands of really small cores. And since we didn't have things like multi-threading and stuff like that at the time, they needed some way of describing how concurrent processing would happen in that environment. So they came up with this idea of an actor being a sort of virtual process that would be able to go ahead and communicate with other actors. They're all logically the same part of the application, but each one behaves like their own little independent microprocess. And that's really the right way to think about actors, is that they're fundamental units of work. So an actor has a mailbox, which in .NET space you can think of as just like a queue, essentially. That actor only does work when messages are pushed into its queue, and everything that actor does while it's processing that message all occurs in a single thread, which means that everything an actor does to its own state, like its internal variables and fields, is always guaranteed to be thread safe. So what actors really give people at sort of a really basic level, if you're using Akka like just totally inside a single process, is a way of doing concurrent programming that doesn't require locks or critical regions or any of the other really nasty sort of synchronization mechanism stuff.
Yeah, I've definitely been in those situations where it's like you look at some piece of code and can I guarantee that the next set of lines are either going to be on the same thread such that I don't really have to worry about much, Or is there potentially a thread transition in the middle, and that's where you kind of get bitten?
Yep. Yeah, the idea behind the actor model is to sort of expose to the software developers who are working on a system a tool that is just guaranteed, has all these sort of safety guarantees out of the box, right? So first guarantee is that actor only does one thing at a time. They're serial, in other words. So that means that anything an actor does with its own variables and its own state is always safe. Second is that actors only process their messages in the order in which they're received. So there's a sort of an ordering guarantee on the order in which that actor's operations are going to be processed. Then the other guarantee is that an actor's state's always private. No one else can go and modify it from the outside.
I see. So I'm a big fan of bad analogies. And so when you were talking, a couple things came to mind. Some of that sounds a little bit like sprites in gaming, if you're familiar with that, because there's very many of them. There's a game loop that runs and they kind of get modified and dealt with. The other one is seems a little coroutine-ish as well. Do any of those work for you?
I'd say the sprite one makes sense, but the difference is you have like one event loop thread that kind of drives the renderer, but in actors there can be a unbounded number of event loop threads.
I see. So the similarity is the fact that you only ever run on one thread and you kind of get some amount of time to run, but the dissimilarity is that there are very many threads, and it's just so is it a one-to-one relationship between actors and threads, or there can be multiple actors on each thread?
There can be multiple actors on each thread. So so if I could visualize this for a second.
Okay.
So imagine you have like a 4-core computer, and let's go ahead and just say there's no hyper-threading for a second here. So you basically have 4 things that can be executed concurrently at any given, microsecond or whatever, right? Well, 4 things to be executed in parallel, rather, if you want to be technical. What Akka .NET does with its dispatching system is you might actually have 1 million actors that all have messages sitting in their mailbox. And our dispatching system essentially guarantees that those 4 threads will go and service all 1 million actors in kind of a fair way based on when the actor had data pushed into it. And each actor will get to process maybe up to 30 messages by default before it has to go back of the line again and wait to process the next round of messages in its mailbox.
I see. So there's kind of a thread pool nature to it. And things like starvation are critical concerns.
Yeah, and we have the ability to go and configure the dispatching system because there's some cases. So, for instance, Akka.remote, for instance, that's the module in the Akka.NET framework you use for letting actors communicate across process boundaries. So, when you start building a distributed system across, like Windows Azure or Docker or something, Akka.remote is like the infrastructure that delivers messages from one actor and one process to another. In that setup, those actors, the system actors built into Akka.NET that actually do the message serialization and transmission, have these soft real-time deadlines they have to adhere to. So we actually go and use a technique called exclusive scheduling, where they get their own thread pool separate from everyone else. So the work queue is always really short for those actors. That way, if there's a 1 million actors on the general thread pool trying to process stuff, these actors can kind of jump to the front of the line.
Right, kind of a VIP status.
Yeah, exactly. And we also have we have some customers who do a lot of IoT with Windows Azure. And in some cases, depending on the type of device you're working with, they might have a scenario where it's like, we have to pull this buffer from this device 400 times a second or we lose frames, something like that.
I believe that, yeah.
And it's like the developer doesn't really have any choice over it because it's like the OEM built it that way, right? And so what they'll do in those cases is they'll put the actors that pull those frames off of that device on what's called a pin dispatcher, where the actor always runs on the same thread over and over again. Now, by and large, Akka.NET does a really good job of managing all of this for you out of the box. But so you shouldn't mess with it unless you have like an edge case like that IoT example. But for the most part, we do a pretty good job with fair scheduling and everything else.
Yeah, one of the things I definitely learned in the IoT space is those pins don't queue.
Nope.
Which is like super annoying. It's like, there's just like electricity there that has to be observed.
Mm-hmm.
So you talked a bit about Azure and cloud. So it's funny, you started by saying actors started out when computers were like completely different and had different assumptions than they have now. But have things come full circle, and now all of a sudden the cloud is like the perfect use case? Because that would be super odd.
Oh, actually, it's a really interesting point. So the reason why the actor model was originally designed in like the early 70s and wasn't actually implemented in a commercially sort of accessible or meaningful way until like the late 1980s when Erlang was originally developed. The reason why there's that huge gap there is because Moore's law eliminated the need for these, let's say living room sized computers with thousands of really slow CPUs in it. We had computers shipped with a small number of really fast ones instead.
Yeah.
But as the internet became a bigger and bigger and bigger place, the amount of computing power demanded by applications became, we sort of grew linearly along with that. And now that we have cloud computing, we can go ahead and essentially just provision new cores and computing power on demand. The actor model basically finally got its sort of day in the sun here when the internet started becoming a much larger place where it wasn't safe or productive to try to run everything on a small number of really high-end computers. Running lots of work happening on lots of cheap commodity computers, which is what cloud computing is usually a more economical model, particularly given that a lot of these workloads people use actors for don't have predictable shapes. So I might be processing 1 million events a second one day. I might be processing 50 million events per second, and then I might drop all the way down to 100,000. And being able to go ahead and provision and deprovision computers to go and do that is a really good technique for trying to keep that sort of cost effective.
Right. So you obviously must talk to a bunch of your customers. What would you say is the split between on-prem versus cloud with Akka .NET?
So it varies a lot by the industry the customer's in and the maturity of the company. This is going to sound bad, but a lot of the decisions around on-prem or cloud have a lot more to do with political stuff than they do with dollars and cents usually. So good example. So we have a lot of major banks, ones some of the people listening probably definitely have accounts with them that use Akka .NET. They have to run everything on premise because of security, compliance, blah, blah, blah. And they just basically have this sort of policy of we don't let anyone who's not one of our people touch this stuff. We have some large healthcare customers that use Akka .NET too. Same exact story. But then we have a lot of startups that go and do interesting things. Like there was a startup I talked to that does real-time risk modeling for insurance, essentially, trying to predict what are the total maximum amount of claims a natural disaster that has these parameters might generate. So they're basically using Akka .NET for trying to run risk simulations and that sort of thing. Well, during a time of year when there's not a lot of hurricanes or wildfires going on, their capacity might be a lot lower than it normally is. So they might go ahead and spin down the amount of computing power they need. So early stage companies that don't have a lot of legal risk, I think, tend to lean on the cloud real heavily because that operational expenditure of paying a monthly fee is a lot more palatable than a big upfront capital allocation for pouring concrete, trying to build a data center.
Yeah, it's OpEx versus CapEx.
Yep. Me personally, where Akka.NET really, its first real production use case was I built a real-time marketing automation analytics for Windows Phone and Windows desktop applications. And we ran everything on a really large, originally it was Amazon Web Services setup. This is back in 2013, so back in the day. And that made a lot more sense for us just because we couldn't predict what our load was going to be. We had one period of growth where our total network traffic during peak hours grew by 600%, for 6 consecutive days. So just stuff like that happened.
Wow. Right. Yeah. So from what you're saying, this isn't the new way to write a website.
Exactly.
You have to have a kind of a little bit of a specific shape of application, and then you kind of fit into the bullseye of the actor style framework.
There's really a couple. So Akka.NET is a little bit different than something like Orleans or Service Fabric actors in the sense that it can scale down to run inside a single process. So we actually have people who ship things like Xamarin applications or WPF, and I think maybe some Unity games now. where they're using the actors to manage sort of concurrent state inside the client app itself. So if you're building a Unity game, you might use the Akka .NET actors on the client to go ahead and drive NPC behavior or something like that, right? So there are some use cases that are sort of strictly related to this like local concurrency type stuff. But the use cases most people want to talk about, though, and this is what sort of gets organizations to really buy into Akka .NET in a major way, are the big distributed server-side use cases. And to make an investment in something like Akka .NET, you probably need to have two different problems that occur at the same time. The first is you have what I would call a soft real-time processing deadline. So here's an example of what that might look like. If I am running a analytics company and I have to guarantee that we will produce notifications about these critical events within N number of seconds of them happening, that's a soft real-time processing boundary. If you're building a trading system, you got to guarantee that trades get posted within a certain window. If you're doing e-commerce, you got to guarantee the order gets sent. And there's like, so you can sort of see like there's like functional structure that kind of defines what those look like. And it's actually more and more the case these days that more and more services have like these sort of real-time processing deadlines. So that's one criteria. The second criteria is unpredictable demand. You don't necessarily know how many of those requests that you have this soft real-time processing guarantee. You don't necessarily know how many of them they're going to be at any given time, but you have to honor that guarantee for all of them, regardless of what the volume is. So when those two requests appear simultaneously, it typically means you're going to need to do two things differently than you'd normally do. So it's not a website anymore. Now what you really have is a stateful application that's running on the server side.
Exactly.
Yeah. And what Akka .NET makes really easy is it makes it really easy to manage state on your own. And it also makes it really easy to linearly increase your ability to process and manipulate state as you add more hardware to your system. So it sort of really gives you that linear hardware scalability that makes it easy to predict how many servers do I need to handle this amount of traffic.
Makes sense. So a couple kind of more closing questions. One, does this run on both .NET Core and .NET Framework?
Yep.
And the other one is, there's some other trends happening in the industry right now. Containerization would probably be top of the list, and so I'm kind of curious how this relates. And I guess the last one is, if I'm interested, where do I go look?
Sure. So the first bit, .NET Core and .NET Framework support. We support both. We've targeted .NET 4.5 since forever when we first started the project. We still do that because we have a pretty decent number of users who are still on that runtime. But we also target .NET Standard 1.6. So that means that if you're running .NET Core 1.0 or 2.0 or 1.1 or whatever, you can consume Akka .NET.
Nice.
We also have a fair number of users on Mono as well. We work on that platform too. So really, any flavor of .NET you want, as long as it's basically older than .NET 4.5, you should be okay. This would be newer than .NET 4.5.
Yes, not older.
Yeah, not older. No,
then,
we occasionally we get requests like, "Hey, you guys ever gonna backport this to .NET 3 or whatever?"
Yeah.
Yeah, not happening.
Containers.
So we actually have a new sample that I finished last week. It's our web crawler sample that we use for teaching Akka.Cluster. If you want to build really large distributed systems, Akka.Cluster is kind of the foundational tool for doing that. So our Akka.Cluster demo now uses Docker Compose, and you can go ahead and scale it up and down via just a couple simple Docker commands. And that's all running using ASP.NET Core 2.0 and the most recent beta of the SignalR for ASP.NET Core. And then I think we also have a container image that I think it's running on .NET Core 1.1, which is kind of a out-of-the-box service discovery engine that we use for Akka.Cluster. But anyway, I think I sent you a link to that, so we can go ahead and post that in the show notes.
Okay.
The other thing that I want to throw out there is that we have a do-it-yourself sort of learn by coding exercise for teaching yourself the Akka.NET syntax and the actor model. And it's called the Akka.NET Bootcamp. It's been around for a few years. We've had about 25,000 people do it. And it is available at, if you go to this URL, learnakka.net. So it's all one word. That'll take you to the bootcamp. And I'll also go ahead and include I'll send you a link to that as well.
Okay, so it sounds like these links are kind of the place to start. And,
Yeah, exactly.
right, and if I, what happens if I run into issues and need a little bit more help?
We have a Gitter chat that we linked to off of the main Akka .NET project that has close to 1,300 people in it last I looked. And so there's about 8 or 9 sort of like core contributors to Akka .NET that hang out in there and answer questions periodically, so me included. So I usually try to spend ideally about half an hour every day answering questions in there. So if you need help with that, you can always go do that. We also do check Stack Overflow for Akka .NET questions, and we answer those. And then worst case scenario, if you want to have someone help you figure out how to architect an Akka .NET application, you can always contact Petabridge. We'll be happy to help you do that.
Exactly. Okay. Well, thanks. I think you shared a lot of great information.
Well, happy to do it. And honestly, anything that helps make .NET developers more productive is what I care about. So.
You and me both.
Yep.
Okay. Well, thanks for being on the show. This has been another episode of On.NET, this time about Akka.NET with Aaron Stannard. Thanks.
Thank you.